highway engineering. In this video, I am going to explain about pavement design. The contents included in this video are: first one, introduction, in that objects and requirements of pavement. Second one, types of pavements. Third, functions of pavement and component. Fourth, ESWL and its determination. Requirements of pavement. The pavement should be sufficient thickness to distribute the wheel load stresses to a safe value on the subgrade soil. The pavement has to be structurally strong to withstand all types of stresses imposed on it. It acquires adequate coefficient of friction to prevent skidding of vehicles. Smooth surface to be provided comfort to road users even at high speed. Pavement should produce less noise when vehicles are moving on it. The pavement should be designed for long design life with low maintenance cost. Pavement. A pavement is defined as a path with a hard surface on one or both sides that people walk on. Types of pavements. The types of pavements are flexible pavement and rigid pavement. In that, the flexible pavement, it means, are those which on the whole have low or negligible flexible strength and are rather flexible in their structural action under the loads. The flexible pavement layer reflects the deformation of the lower layer on the surface of the layer. If the lower layer of the pavement or soil subgrade is undulated, then flexible pavement surface also get undulated. A flexible pavement consists of four components. First one is soil subgrade, second sub-base course, third base course, fourth surface course. In that, the first one is soil subgrade. A soil subgrade is defined as it is made up of native soil that has been compacted to withstand the load above it. Second one is sub-base course. Is the layer of material beneath the base course, and the primary function are to provide structural support, improve drainage, and to reduce the intrusion of fine from the subgrade in the pavement structure. Third one is base course. It is the layer of material immediately beneath the surface of binder. Surface course is a layer directly in contact with traffic loads and generally contain superior quality material. The following are the images of flexible pavements. The following are the flexible pavement layer transmit the vertical or compressive stress to the lower layer by grain to grain transfer through the points of contacts in the granular structure. A well compacted granular structure consisting of strong graded aggregate can transfer the compressive strength through a wider area and thus forms a good flexible pavement layer. The load spreading ability of this layer therefore depends on the types of material and mixed design factor. Bituminous concrete is one of the best flexible pavement layer materials. Other materials which fall under the ground are all granular material with or without bituminous binder or granular base and sub-base course. Materials like the water-bound macadam, crushed aggregate, gravel, soil aggregates, mixes, etc. The vertical compressive stress is maximum on the pavement surface directly under the wheel load and is equal to the contact pressure under the wheel. The lower layer have to take up only lesser magnitudes of stress and there is no direct wearing action due to traffic loads. Second one is rigid pavement. It is defined as It is constructed from cement concrete or reinforced concrete slab. The design of rigid pavement based on providing a structural cement concrete slab of sufficient strength to resist the loads from traffic. The following are the images of rigid pavements. In the rigid pavement, the stresses are not transferred from grain to the lower layer as in the case of flexible pavement layer. The rigid pavement are made up of Portland cement, concrete, either plain, reinforced or pre-stressed concrete. The plain cement concrete slabs are expected to take up the load up to 40 kg per centimeter cube flexural stress. The main point of difference in the structural behavior of the rigid pavement as compared to the flexible pavement is that the critical condition of the stress in the rigid pavement is the maximum flexural stress occurring in the slab due to wheel load and the temperature changes, whereas in the flexible pavement it is the disturbed of compressive stress. My next topic is functions of pavement components. In that, first one is soil subgrade and its evaluation. The soil subgrade is a layer of natural soil prepared to receive the layers of pavement materials placed over it. The loads of the pavement are ultimately received by the soil subgrade for dispersion to the earth mass. It is essential that at no time the soil subgrade is overstressed. It means that the pressure transmitted to the top of the subgrade is with the allowable limit not to cause excessive stress condition or to deform the same beyond the elastic limit. These are the tests known for strength properties. Second one is sub-base and base cores and their evaluation. The layer are made of broken stones, bound or unbound aggregate. Sometimes in the sub-base cores, a layer of stabilized soil or selected granular soil is also used. In some places, boulder, stones or bricks are also used as a sub-base or soiling course. One is wearing course and its evaluation. The purpose of the wearing course is to give a smooth riding surface that is dense. It resists pressure exerted by the tires and takes the wear and tear due to the traffic. Wearing course also offers a watertight layer against the surface water infiltration. In flexible pavement, normally a bituminous surfacing is used as a wearing course. The types of surface depends upon the availability of material, plants and equipment and upon the magnitude of surface load. My next topic is equivalent single wheel load. To carry a maximum load within the specified limit and the carry greater load, dual wheel or dual tandem assembly is often used. Equivalent single wheel load is the single wheel load having the same contact pressure which produces same value of maximum stresses. Deflection, tensile stress or contact pressure at the desired depth. The produce of finding the ESWL for equal stresses criteria is provided below. This is semi-rotational method known as buoyant or forced method based on the following assumptions. The equivalent single wheel load is given by following equation where P is the wheel load, S is the center to center distance between the two wheels, D is the clear distance between two wheels. Thank you for watching.